Hey guys, it's your second video on the density pre-lab you'll be doing next class. In this lesson, we're just going to talk about density, why it's a good measurement to take in a lab, and how to calculate it. Also, some new vocab words are going to be about intensive and extensive properties. Did we make a penny made of gold? Now, I know we talked about this a little, but you're going to have to do some more experiments to really prove to me with some evidence that we did not make real gold. In order to do this, we're going to run more tests. So far, we know that the color changed to gold. So far, this is a good evidence that we did make real gold, so we need some other stuff too. I do not want you finding out hardness, because I don't want you to bite it. Although real gold, if you did bite it, is a soft metal. Therefore, you would see some teeth marks left in the gold, but you're not going to do this. You could test its malleability. Gold is, again, soft, so if you were to hammer it, it would be easily shaped into different shapes. But we're not going to use hammers. I don't want any fingers broken. We could do the boiling point of gold, and we could boil it. However, as you see by this very large number, we are not going to reach this high temperature, so boiling is out of the question. How about melting, you say? Well, look at this number. Gold melts at a very high temperature. We do not have the equipment in our lab in order to reach this temperature. It's not going to happen. Since we can't melt the gold, we can't determine viscosity. Viscosity is only a term used for liquids. Therefore, our remaining possibilities of some physical changes are mass, volume, and density. We need to determine which one of these is going to be best. Out of the three possibilities of mass, volume, and density is going to be the best measurement to take over mass and volume. This is because density is an intensive property, whereas mass and volume are both extensive properties. An intensive property is a physical property not dependent on the size or the amount of substance that you have. Examples of intensive properties are temperature, density, and hardness. So for example, you have a glass of water and a jug of water over to the right hand of the screen. No matter if I have that small glass of water or the large jug of water, if they're both in my fridge, they're both going to be the same temperature. Therefore, temperature does not depend upon how much you have of the substance. The same is true for density. If I have that small amount of water or the large amount of water, they're both going to have the same density if I were to calculate it. On the other hand, an extensive property is a physical property that is dependent on the size or how much of the substance you have. This is true for mass and volume. So for instance, you guys know that this small glass of water is going to have less mass than the large jug of water. The small glass of water also takes up less space. It has less volume than the large jug of water. So mass and volume depend upon how much you have. They are extensive properties. So since density will always stay constant no matter how much you have of a substance, you will be conducting density experiments to identify elements. Density is calculated once you know the mass and the volume. So even though mass and volume, we don't want to stop there, we want to keep going to density. The mass is defined as how much matter is in an object, and it's measured in grams in the science lab. The volume tells you how much space the object is going to take up, and it's measured in either liters or cubic centimeters. You then use these two properties to calculate the density, using the formula density equals mass divided by volume. Here's a practice problem to help you figure it out. Let's say I give you a piece of a golden substance that is 7.5 grams and it has a volume of 0.388 milliliters. Would you determine this substance to be real gold or fool's gold? Let me walk you through this. You're going to start with a formula, density equals mass divided by volume. You're then going to substitute your values in, come straight from the word problem. Solve for D, put it in your calculator. When you do that, you're going to get density equals 19.3 grams per milliliter, which is also equal to 19.3 grams per cubic centimeters. So milliliters and cubic centimeters are equivalent. It depends on how you're going to write it. To figure out if this is real gold or fake gold, you're going to compare it to a chart of densities. So if you look at this chart, you can see that the density of gold is 19.3 grams per cubic centimeters. That means you have real gold, since the densities are equal. In the lab, you're going to be given several different metals, and I'm going to ask you to tell me what kind of metals did I just give you. you're going to be using a scale or a balance to find the mass. Then you're going to be using either a graduated cylinder to find the volume or the ruler method. I'm going to tell you how to do both of them. Here you see the mass, or the scale which you're going to find the mass on. It is very important that before you put any metal pieces on here that the balance reads 0. If you turn it on and it doesn't read 0, there should be a 0 button on it. Just press it. Then you're going to be using a graduated cylinder if you choose to find the volume. The important part about using graduated cylinders is that you measure the meniscus. You can see in the diagram that the eye is looking at the meniscus. It is the most bottom part of the liquid level. You also want to get eye level with it. You don't want to read it above or below. Get eye level and read it exactly. If you use the graduated cylinder, you're going to be doing the water displacement method. What that means is you're going to be dropping the metal into the graduated cylinder. You can put as much water, as little water as you want into the graduated cylinder to start with. Just make sure that the metal is completely covered in water. Notice in the picture when you drop the metal pieces into the graduated cylinder, now the water level raises. Since the first one went from 15 to 17, that means that the piece of metal has a volume of 2 milliliters. The second one went from 15 to 19, that one has a volume of 4 milliliters. That's called water displacement. If you choose, you can do the ruler method, and you guys know in math class that volume equals length times height times width. However, you can only use a ruler method if you have a regular shaped piece of metal. If I give you a weird shaped one, the water displacement method is usually the best one to use.